We're going to be discussing lesson 3.3 in a few different parts. In this first part, we're going to look at rate times time equals distance. And we've talked about this before. We talked about earlier in this course. We know that rate times time is equal to distance. And now that we have another way of solving things, solving systems of equations, I believe these problems become a little bit easier. And so what we're going to do here, we're going to go through this first example with our distance formula, rate times time equals distance. So we have two buses are 412 miles apart. They head toward each other. One travels 3 miles an hour slower than the other, and then they meet in 4 hours. What's the average speed of each bus? And speed we know means rate. So what's the average rate of each bus? And so as we read through that, one thing we realize is we want to find the rates. And what's different now with using systems of equations, we can actually have two variables. Before we tried to get everything into just one variable. But so what we're going to do, since those are our unknowns or our variables, we can just let, we'll use x and y, let x equal the rate or speed of bus 1, and we'll let y equal the rate of bus 2. So those are our two unknowns, and we're going to try to solve for those as we work through here. We're still going to set up a table like we did before. We know that rate times time is equal to distance, and we have two situations here. We have two buses. So we can say, well, we have bus 1 and bus 2. So subscripts just differentiate the two buses. And then we'll look through here and see if we can plug things in. We have rate of our first bus. Well, that's what we just talked about. Those are our unknowns. So x is the rate of the first bus. The time of the first bus, well, as we read through here, it says they left and then they meet each other in 4 hours. So our time is 4 hours. And our distance is, well, we know distance is rate times time. So x times 4 is 4x. We don't use that 412 yet. Don't try to use that yet. We're going to talk about that in a little bit, and I'll point that out where that comes into play. Down here, we're doing something similar. We got our rate of the second bus. Well, we let y equal that. Again, they left and they meet in 4 hours, so this is actually also 4. And we know distance is rate times time, so y times 4, which is 4y. Maybe I could have done this at the beginning, but let's look at our scenario in a quick sketch. We have two buses that are not at the same place. In fact, we know they are 412 miles apart. And this one, they're traveling towards each other. So here's bus 1, and here's bus 2. Looks like a 13, bus 1 and bus 2. Now, I purposely did not make them the same length. If they were traveling the same speed and traveled for the same amount of time, this would be nice and easy because they would meet right in the middle, but one's traveling slower, they're traveling the same time, so one's not going to go as far. And so that's kind of the difficulty here and why we have to set it up this way. Another key point here that you need to know or understand is we're going to come up with two equations, and one equation usually, so you have two equations, so usually one deals with, we'll have usually an equation that relates the unknowns or our variables. And then there's also an equation that relates the distances. And so we have to write two equations. So there's usually an equation that relates to unknowns. Well, our unknowns are x and y. X and y are the rates. And the one thing we see about rates here is one travels 3 miles per hour slower than the other. It doesn't say if it's the first or second or bigger bus or smaller bus or the one traveling east or west. It just compares them, so it doesn't matter which is the faster or slower. So for this one, we know that x, so let's just take the rate of the first bus. Let's say it's 3 miles an hour slower than the other. Well, so x equals, well, for other ones y, it's 3 miles an hour slower than y. So take y's rate and subtract 3 from it. So if this one was 20, if y was 20, this would be 17. So it's 3 miles an hour slower. So there's one equation. Next, we want to come up with an equation that relates to distances. Kind of all over the place here, but when we discussed this back in a previous chapter, we said distances would probably fit one of three things. The distances might be equal. So these are kind of our three possibilities. Distances are equal. That's our first possibility. Second, we said that the sum of the distances is a given amount, or something to that effect. The sum, so both the distances added together, sum of the distance equal, sum equals a given number. And the last one, which is a little more rare, but one distance is equal to, so one distance equals the other distance. And I know that right now that looks like the first thing, but I'm not finished. Plus or minus a given amount. So you would have to add or subtract some amount to one of the distances. So it's going to fit one of these three things. Which one do we have here? Are the distances equal? Well, I already mentioned they're not going to be equal because one's going slower than the other. Is the sum of the distance equal a given number? Well, yes, that is the case here because we have the two buses coming towards each other and they meet after 412 miles. So the distance of the first bus plus the distance of the second bus will equal 412, and that's what our second equation is. So what is the distance of our first bus? We come back here, it's 4x. Bus 1, its distance is 4x. Plus distance of the second bus, it's right here, plus 4y equals 412. And we can go ahead and solve this. This one actually looks nice for substitution because x is equal to y minus 3. We can say this is 4. Since x is equal to y minus 3, we can substitute that in there. Plus 4y equals 412. And now we're well on our way finding the rates of each bus. We can distribute here. We got 4y minus, distribute this, minus 12 plus 4y equals 412. Add 12 to both sides. Doing a couple things at once here because I'm adding 12 to both sides, and then 4y plus 4y is 8y. So 8y equals 424. Divide both sides by 8. And if you divide 424 by 8, we get 53. So y is 53. And remember, y represents the rate of the second bus. The nice thing is we can come back up to this equation right here, and that helps us find x nice and easily. We know x equals y minus 3. Well, we just found out y was 53. And and you get 50. And these were in miles per hour. So we found the rates of the two buses.